I want to do a little bit of context setting about Devon and what we are, for those of you who may not be super aware of what the North American onshore oil and gas industry is all about. Some of you who were in my session yesterday, this might be a little bit of a repeat for, but I'll try to go quickly. We're primarily an oil and gas operator in the North American continent. In these dots down here in the U.S., we mostly do horizontal drilling, hydraulic fracturing, which has all kinds of mixed reviews in the press that we constantly try to make sure that we're clear about and are actually managing the environmental impact pretty carefully. Up north, we produce heavy oil. It's steam-assisted gravity drainage, which means we've got 3 plants up there for us that each run through about 1.4 million liters of water a day to produce about 35,000 barrels of oil a day in each of those 3 plants. So they're basically big water separation plants with a bunch of pipeline and injector and producer wells out in the field up there. So very different, 2 very different modes of operation, both very asset intensive, one very distributed set of assets and one very concentrated set of assets. We were founded on innovation. Our founder, who only just recently had to leave the board because he aged out, he's still an incredibly active guy, founded our company with a tax loss carry forward, which means he founded it with imaginary money. And he basically, it's true. Basically from there, he grew the company through basically bet the farm acquisitions and true commitment to innovation, right? So not only was he very innovative in the financial and legal structural side of things, he was a fantastic leader for us when it comes to being the owner of what it means to take a risk from a technology perspective. And Devon, I'm quite proud to say that Devon actually is the company where the first time hydraulic fracturing and horizontal drilling came together, which really changed the world energy economy in a way that I think nobody expected. Certainly, we didn't even anticipate, because when we started doing that, natural gas in the North American basin was considered to be a rare commodity, meaning we had much more demand forecasted than we had supply. It was trading at about $12 an MCF. 4 years later, it was basically worthless. It was $1.75 an MCF, which we would sell it for almost what it cost us, and actually we're continuing to sell it for almost what it cost us to pay a transporter to take it to market. So we make almost no money on our gas. The only reason we sell it is because it's environmentally irresponsible to just burn it or vent it, right? So we're selling it, but we're basically making no money on natural gas anymore. We are only making money on oil. A few more key points here. The big eye-opener for me, this first bullet point, was a huge eye-opener for me. We think about commodity markets as being driven by a basic supply and demand curve, right? When the supply exceeds demand, prices will go down. When demand exceeds supply, prices will go up. But actually, the oil and gas paper market is 100 times the physical market, meaning there's 100 times more hedges out there per barrel than there are barrels, which is unbelievable to me. But what it really means is the price of our commodities is essentially controlled by the sentiment of the companies that manage those trades, not by any reality of the physical market. Now, the sentiment, of course, is informed by storage levels in various parts of the region, potential unrest in various parts of the world, and that sort of thing. But very little hard science actually defines the price that we take for our barrels. A lot of it has to do with somebody's opinion, and oftentimes, in quite a frustrating way, they are increasingly the opinions of people who are not very close to our industry. They are not very aware of the realities of what it means to produce a barrel of oil, to develop a barrel of oil, and are really pretty far from what it means to add production or manage your production, add a barrel into the supply chain, move a barrel from one part of the world to another. They just look at some facts and figures and I've seen them do it. It's kind of frustrating to watch. My whole world is driven by some analyst's spreadsheet model that has about 6 cells on it they're updating every day. So that's incredibly frustrating, but in a way it's a reality. And a reality that for us means that we have to be aware of that and stay competitive in spite of that, sort of ignore that in a way, but deal with it as just a cost of doing business or a reality of doing business. Having said all that, this shale change for us, this flip of the market, which is basically going from a place where the natural gas and oil prices that we take were defined by somebody's expectation of global demand, meaning population growth was a big driver for that, to being in a world where we actually can bring, with the shale development, we can bring on production as fast as demand changes. We can bring on production in 6 to 8 to 12 weeks, which is an incredible game changer for the industry, because it used to be, and before, say, 2012, the industry, our industry, was incredibly dominated by large capital investments in far remote places of the world. That is the expected supply from those projects was really what drove essentially the other side of the commodity equation. So that has changed dramatically. Also, as part of that, this ubiquity of the shale development in the North American basin has caused us to essentially to be the gap we make up the gap in the world demand and supply in the North America, which is incredibly frustrating to some of the OPEC countries that used to be able to take that up and take that extra barrel of revenue. And so that's, again, changed the world political dynamic as well. But the competition for that barrel now in the North American basin is incredible, and it's very fast-paced. Meaning, if I can get 1 penny better margin than the other guy, which means that I can produce 1 barrel at a little bit lower price than the other guy, then I'm going to do that. And we're all out there doing the same thing. And the way to do that fundamentally has changed our business. We have got to really work differently in order to be fast at capturing that technical advantage, to be very, very quick at reinventing the way we operate, the way we execute. We call it operations, but drilling completions for us has become like a factory model. It's not a big capital project anymore. It's got to turn and go quick and be effective. So I'm going to give a couple of examples of where we're using technology in different ways. But I hope that what you take away from this is not the technology theme. Read through this, that what's happening is we're having to work together, and we're having to work together in more effective and different ways. And actually what's happening is everybody's jobs are changing, not just operations. Everybody's jobs are changing in this whole process. Everybody from IT all the way to the front office. So I'll try to get through this couple of examples and highlight some of those big changes in my time limit, but I've packed a lot into this, and so I want to try to make my points here, but I may not drain every slide, so bear with me a little bit here. I talked about those SAGD, those steam-assisted gravity drainage plants up north. They really are huge plants, also with lots and lots of linear assets as well, pipelines that go out to these pads that have the injectors and the producers. So our asset integrity team up there has the unenviable problem, basically, of having to keep up with inspections, certainly in a plant that's full of, and this is just a picture of part of the plant, that's full of heights, full of high energy environments, full of opportunities for somebody to get hurt. Some of our biggest issues have actually been inside of huge vessels where we've had the support parts collapse and things like that. So not only is it external inspections, but it's also needing to go and inspect internally. Also, this group has to go and do inspections on pipeline and pad locations during times of year when it's completely inaccessible, meaning you would sink into the mud. It's like tundra that melts every summer. And so to try to drive a truck out is essentially futile. It really is futile. I've been out there I made the mistake of going out there in the summer after everything thawed, and everybody's out there with waders. And it's not because of water, right? It's because mud. And they all leave their waders at the edge of the houses. The other side of the equation is it gets incredibly cold. And some of the most deadly roads on the planet are actually in northern Alberta. If you slide off the road, the likelihood is you'll freeze before you're found. If you're coming at traffic, so there's these roads out there where you are coming at each other at 100 miles an hour, essentially net 140 miles an hour or so, and if you have impact, again, you're probably going to be dead before you're found. So it's incredibly dangerous work for these guys to get out there and actually physically touch their hands on the assets. At the same time, they of course have the demand to increase the frequency and the quality of their inspection work to try to improve the reliability and actually the cost effectiveness of the work that we're doing from an operations perspective. So what did these guys do? See if I can make it go. There we go. So really, these guys didn't have to do any invention. What they really needed to do is step back and think about what is out there that's readily available for us to bring in and make this easier. And you can see from the picture, the obvious answer is, we should be doing this with drones, right? We should be doing this with unmanned vehicles. We should be finding ways to fly over these pipelines, to fly over these assets, to take pictures, to actually, they're starting to use crawling drones as well to go inside of things and take imagery, to check for corrosion. So it's actually this is not rocket science. This is readily available stuff. And we didn't have to train drone pilots or figure out how to get permits. There are already companies out there that are working with the regulatory bodies in the U.S. It's the FAA. I can't remember the name of the regulatory body in Canada off the top of my head, but there's essentially a regulator that is the same regulator that governs aircraft. They're excellent at getting permits to develop flight plans for drones and drone vehicles in the air. And so we are now flying regularly pipelines. We're flying over assets and doing inspections. We're using drones to go and inspect stacks. And again, this is taking people out of harm's way. But what's really important here is they're not just taking a picture and getting a report. What they're actually doing is building a foundation from which they can do more. So these guys have a great baseline of asset data. Every time they do an inspection, they're working with the IT organization to enhance the way that we manage that data. They're linking those inspections, those images, to the piece of equipment. So every time we go out there and take an image of a piece of equipment and we want to look at corrosion, the guys can sit there and look at the 2 pictures over time, or 3 or 10 pictures over time, and they can see what's changing. They're also starting to set it up for analytics, where as they increase the number of inspections, instead of adding guys to the team to look at these things, what they're doing is actually using a computer to do video analytics and let the inspection team know that there's something they should probably go dig into more deeply. So they're doing more inspections, they're doing them more safely, but the important thing is they're managing their data in such a way that they can add capability and reimagine their work. And so what's happening is the inspection team is working closely with the data science group, with an IT group, and with the operations group to make sure they're doing the right kinds of inspections, that we're building a foundation of managing this information as a base, that we're setting ourselves up for the future. We're future-proofing this whole thing by managing the data and building capability on top of that. So what could have just been a deal where we pay a group to go out and do an inspection and give us a paper report on PDF, we're doing that very differently. Instead, what we're doing is we're getting the raw information in, we're managing that, and building a foundation and increasing the pace with which we are able to do higher quality work. And this is not replacing jobs, frankly, other than guys climbing to the tops of stacks. Those jobs are changing for sure. They're being replaced by drone operators in much safer roles. But the rest of the work that we've done, which is what we've always done, is just changing. We're getting more mature and doing a higher quality job through that collaboration. So obviously the impacts here are safety, environment, improvement. Obviously we're not seeing the kinds of leaks that we were when we couldn't get out there and do good inspections. We're certainly doing this at much lower cost. We're doing more high quality work at a much lower cost. And I just showed this as one little example. So this is one of our steam pipelines that's headed out to one of the pads, actually a whole set of pads in Alberta. And you can see this one on the right. The spacing is a little different. Actually, that one's right about to slide off the riser. And so they caught this because they were doing rapid frequency drone flyovers as we were starting the plant back up, which means we take this pipeline from about minus 40 degrees C to about 400 degrees C over the course of a couple of days. And when that pipe riser started to bind with the pipe was about to slide off. This catch allowed us to stop the startup process, which we would never have done without these drones. We shut the startup process down, and we were able to catch it before the pipe failed in plastic failure, right? So actually we just shut it down, we fixed the riser, and started the plant back up again. And instead of having a huge expensive repair of a very specialized piece of pipe and a whole bunch of lost production, a week of lost production or more, because we were gonna have to get that piece of pipe fabricated and shipped if we weren't able to find it in one of our competitors' inventory that they were willing to just donate to us. This saved us millions and millions of dollars, both in direct and indirect. And also, again, we were able to do this. So you can see they used to drive out here and do these inspections. You can see the truck tracks, but we don't do that anymore. So it's a great success for us. Again, this just happened this summer. I thought it would be a good example. Saved us hundreds, probably $100 million ultimately, all in with lost production and every other aspect of this, including the environmental cleanup, which would have been a huge deal because this is very, very briny water. So we'd have been out there cleaning up this water for a long time. I'm going to talk a little bit about a shale technology application. This is not bear with me, this is not an asset management example, but I thought it'd be another typical type of example of the way we're working very differently in our industry. You can see the way that we do this kind of work. We drill those wells, we drill them horizontal. This is the fracking part where we perforate right now is what you're about to see. We shoot shrapnel basically out through the casing and the cement, and then we pull that gun back out and we come in and we pump sand and water. The sand is called proppant. I don't know why they call it proppant instead of sand, but it's sand. I never knew there were so many different kinds of sand in the world, but apparently there are very, very special kinds of sand. Some make good proppant and some don't, and there's a whole science and argument around that. Anyway, this is fracking in a very simplistic way. This is what you may read about as various opinions about good or bad. But being able to do that allows us to produce this oil out of a much higher surface area of the shale rock, which is fundamentally what made this economic for us. We still only produce 15 to 20% of the oil in place. Even with all this amazing technology, we're still only accessing 15 to 20% of the oil and the hydrocarbons that are actually in that rock. In the past, when we did this drilling, and I'll jump to the next slide, it's incredibly complicated. So that picture makes it look like we're drilling into a nice, cookie sandwich, right? But it isn't like that. You can see at the top there, the squiggly line is actually the little dark line that goes through the yellow and the orange. That's a well that we landed exactly in zone, 99% in zone. So in zone is not a nice straight line. It's actually a very complicated thing that we optimize in real time. And actually, this is an example of the subsurface model. So I joke with people that really the only thing we're trying to do in the oil and gas industry is create a high-resolution model of the Earth's crust. And if we can do that, then we'll actually be able to beat the competition, because the higher resolution model I have of the Earth's crust, the better I know where to land a well and how to develop oil from that well. It is the biggest big data problem there is out there. So we do everything we can to try to develop a very accurate model, but as we drill that model, we learn, and that model changes in real time. It used to be we developed a well plan. The well plan was handed from one department of our company to the drilling guys. The drilling guys would drill the well plan, and we would find out that we were only 70 or 80% in zone once we figured out that the zone that we thought we were landing in was really not where we thought it was. In fact, it moved on us. It didn't move. It moved 1 million years ago, but we didn't know where it was, or more, 150 million years ago. You can also see that what we're trying to do is drill around a bunch of other wells that are out there. If you hear about all the development that's going on in the Permian Basin, there are hundreds of vertical wells that are producing oil out of the same formations that we're drilling into. So imagine trying to drill through a spaghetti bowl of other wells and land exactly in the target zone that you're trying to drill in, which is not a nice Oreo cookie sandwich. In order to do this, we absolutely started with the basics. We just said we need to get data, we need to organize that information, we need to get a cross-functional team. We created a well construction decision support center. In this center, we have the geologists, the drillers, the completions engineers, operations input in terms of what will work and what won't, in terms of pad layout and that sort of thing. They manage this real time. We get sub-second data off the rig. We used to not get data except sort of manually input data on a daily basis, and usually a much more detailed download on a weekly basis. We now get real-time sub-second data and full downloads from the drill bit. You can't get all the data off the drill bit except when you pull the pipe out of the hole, which is a huge problem. To do that, it's very expensive, waste of time, so you want to do that as little as possible, but we can get some data real-time off of the rig, both the rig information like torque at the top, and there's some ways that we use the mud. We actually do sort of sonar through the mud and get some low-res data real-time as well. Started off with just basic data visualization. Where are we? Where are we going? As best we can tell. And then we realized that actually a lot of the instrumentation we have on these wells is 90 feet behind the drill bit, the tip of the drill bit. So if you think about 90 feet, I don't know if it's here past the back of the wall, 1 or 2 degrees off, and you're completely out of zone. So we built a predictive analytic model to tell us, based on where the instrumentation is, where's the drill bit. And we got incredibly accurate with that. Again, statistical analytics, using all the data that we were pulling in real time. Then we started looking at optimizing the landing location of the well. Again, updating our model based on looking at mud samples and what are we actually seeing in the drilling process in terms of the rock properties changing as we go through. So this process of developing capability in the WellCon Center for us has led to us being able to hit target 99.5% of the time. We've taken 30 to 40% out of our capital costs in drilling wells because we're being able to execute our drilling programs that much more efficiently and effectively. We're having fewer issues like broken, twisted off bits and stuck pipe because we're able to look at torque and location in the well. So again, the points are the efficiencies that have come from this are absolutely game-changing for us in our industry, and certainly a huge part of what's making us, well, allowing us to stay in business fundamentally anymore, but making us competitive and we think a leader in what we do. The way this gets done is we have a group of drilling guys who are incredibly open-minded. They didn't really know how to do what they wanted to do, but they had a vision. They brought in IT, they brought in data scientists, they brought in operations, they brought in our third-party vendors, our drilling contractors. Everybody's at the table. Everybody's working together. We bite off one piece of work. We have a vision, which is to fundamentally change the way we work. The vision now is an unmanned rig, a fully autonomous rig, all built on the back of a tremendous amount of work and all fully optimized, recreating the optimal output consistently and safely. We today still have 3 guys who stand on the rig floor in probably the most dangerous location anywhere in the industrial world and change pipe, tighten up, make up pipe, which is, you talk about guys that are gonna lose an arm. There's equipment on that location that it could easily lose their arm. And if there is a kick, we call it a gas kick, they're standing right above the well. And they're gonna get lit on fire if they're out there, right? We wanna get these guys out of that harm's way. So the more we work with our partners to reinvent the way their equipment works, the more we integrate the way we operate with the way they work, the more we integrate our capabilities internally, the faster we're able to develop new capability. And it starts with basic data management, and on top of that, it's partnership and continuous improvement on top of that foundation. And it starts slow, but what's happening is it's increasing. We've just recently developed a data analytics model that can geosteer a well in a way that we thought was secret sauce, like talent, like cricket batting, but it's not. It turns out you can actually recreate that with the machine learning algorithm, right? And again, that's not what we really want our guys doing. We want our guys doing the planning. We want to move them earlier in the whole thought process. We want the machines to just do the execution. The great thing is these guys, everybody that's involved in that WellCon, they're all measured by the same output, the same goal, which is just improving our capital efficiency and our execution. They're all totally motivated by that same goal. They're one team. They're organizationally not one team, right? If you look at their hardline organization structure, they're all over the place in terms of who they report to, including outside parties. But if you ask them, it's the NASA janitor, what are you here for? Put a man on the moon. It is exactly that scenario. These guys are all there for one purpose. And it's incredible to go in that center and watch these guys at work because they're all passionate about one set of goals. So thematically, again, I'm trying to sort of leave you guys with something to think about here. I know I'm the IT guy, but I'm never about technology. I mean, technology is really fun and interesting, but there's so much technology out there in the world that we could all capitalize on. That's actually not what we should be focusing on. We need to focus on different ways of working. So in both of these examples, what's happening is the jobs out in the field are really changing. They're still there. We still have guys out there. We want to get guys out of harm's way as much as we can, but we still have guys out there because the machinery is getting more complicated. Maintaining the machinery is getting more complicated. But doing that, we can hopefully change the type of maintenance that's happening and move people out of the danger zones that they're in today. Our engineering guys, who all have MEs and petroleum engineering degrees and chemical engineering degrees and geological engineering degrees, their capabilities are expanding. So they're moving out of their core disciplines, not moving away from that, but they're adding to that. They're complementing that with an understanding of data and data science. Most of them start by just being data hogs. Give me all the data, I want to do some stuff. But then they start partnering with people and they start realizing, hey, if I learn how to do statistical analytics, I can learn about varying my methods so that I create statistically interesting combinations of scenarios, and I can start to be more predictive in the way my work is happening, and do a better design and do a better plan down the line. We drill hundreds of wells a year. The opportunity to optimize is now, and it's next month, and it's the month after that. It's constantly evolving. So our engineers' jobs are growing, and their sophistication is growing. We had early scenarios, we tried to apply statistical analytics, and we realized that early success is your greatest enemy. They drilled a well that was successful. They drilled the exact same well over and over and over again, which you'd say, well, that's good, right? But they had no variability in their data set, so we had nothing to use to optimize anything. So now we're learning about the value of variability and fine-tuning your methods, not too quick, right? Don't fine-tune too quick. We're definitely redefining jobs throughout the whole process and focusing a lot more on data management. Data management's impossible to write a business case for, but it is fundamentally the foundation for continuous improvement and accelerating continuous improvement over time. Data management for us used to be an IT thing. And the IT guys have no idea how to manage your data. They have no clue. They think they do. They will read you the book. I've had people who are part of every data management society in the world, but they have no idea what data is valuable to you as an operator or engineer. No clue. You need to own your own data. They're there to help you. They're there to help you get access to it, organize it, manage it, use it, and build from it. That's what they're there for. They might tell you they know everything about data management, but I guarantee you they don't. And I'm an IT guy, right? So it's coming from me. Integrated teams, I talked a little bit about this, well, a lot about this yesterday and also today. Having an integrated set of capabilities, the value of diversity, we talk a lot about that in the industry. To me, that is just bringing people together who have very different perspectives on the problem and can bring their talents and passions. The secret sauce of that for me is to have them aligned to one set of goals. If everybody's still got their legacy department goals that they're working from, it isn't going to work right. You got to go, again, as the IT guy, when I put a guy in that team, I tell him all of your IT measurements are gone. You're measured by the same thing as the rest of that team. And it completely changes their behavior and their focus. There's no more of this, hey, but I did my part. That's what we get rid of, which is good. Data analytics is driving creativity, and I think that's driven most effectively by the subject matter experts. So they need to learn how to bring that kind of mentality to their work, and then the creative juices start flowing, and it's really exciting to see. Because we try things, they fail, but it doesn't matter. 2 weeks worth of investment, and we just try something else. And what we did was we learned something, either something that just totally isn't going to work, or we learned that we were just not quite in the right zip code, and we need to change our thinking a little bit and go faster. And I can't underestimate the value of bringing your partners to the table as quickly as possible. And actually, we were talking in the back of the room, not only your partners, but your competitors. There's a lot of this stuff that we like to think is competitive advantage, but frankly, our competitors are working on the exact same things we are. And a lot of the partners that we work with are the exact same partners. So as soon as we come up with a solution, guess what? The partner's going to go work with your competitor and offer them that solution. So if you identify the 1% of the world that you're competing on, great, protect that. 99% of the world, there is absolutely no reason why you can't collaborate with your competitors and with outside partners. Just recognize that stuff's going to be shared IP. It's okay. Everybody's game rises. Everybody's game rises. The 1% you think is your secret sauce, protect that. So I've talked a little bit about a few of these points, but really fundamentally my message is technology is not the challenge, right? There is so much technology out there, so much digital technology out there, so much engineering technology out there. It's an infinite cost to try to implement it all at the same time and zero value. We saw that with ERP implementations. I was part of them. We thought we had it all answered. We thought we were doing it the right way. It was way too big and way too expensive and way too slow, and we need to do everything completely differently today. And I'm a huge advocate of doing that differently. You've got to bring diverse teams together, encourage ideas from everyone. Everyone's got a valuable perspective. Otherwise, don't invite them to the conversation. Don't have somebody come in the room and tell them not to talk. Everybody's got to have something to contribute. Integrating teams, to me, is not just about putting people in the same room. It's about aligning goals, which is hard to do. It means you need to get leadership buy-in from all those folks, but it's very, very valuable when you can do it. Promoting personal development is important for everybody involved in this. Everybody's skills are going to change, which means you need to be prepared to support their development and encourage them to get out there and learn new things and learn new skills.